Okay, so we're on page 125 of the Math 20 Absolute Value Workbook, and we're looking at Dividing Radicals Part 2, Lesson 5. And so just a little bit trickier than having a single term in the denominator is when we have a denominator in binomial form. And so how do we rationalize the denominator for that? So remembering that rationalizing the denominator means that we want an integer or whole number value in the denominator. We cannot have a radical. And so the process of doing that is by creating what we call like a difference of squares. So by multiplying the conjugate of the denominator. So we're not concerned at all with what is in the numerator. Obviously, we're going to need it to adjust it, just similar to finding an equivalent fraction. But our whole goal is to come up with a denominator that is without radicals. So if you recall, going back to multiplication of radicals and binomial radicals, so anytime we had something such as, let's go with 2 minus root 3, if we make that into kind of like a difference of squares, so difference of squares would be exactly the same, so 2 and the root 3, except instead of minus, it's going to have plus root 3. And when we multiply those together, going through and doing FOIL or box method, whatever method you use to multiply binomials, what we recognize is that those outside and the inside terms cancel each other out, making 0. So we're just left with the first term, so 2 times 2, which is 4, and then the last term, so negative root 3 times positive root 3, which is minus 3. In this case, it equals nicely out to 1. So it's that whole idea of if I have x minus y times x plus y, really we're just going to be squaring that first term, x squared, and then the outside is plus xy, the inside is minus xy, that makes 0, and so then we're left with minus y times positive y, so minus y squared. So squaring the first term minus squaring the second term. So in this case then, my conjugate for that denominator is going to be root 5 plus root 3, but whatever I do to the bottom, I must also do to the top. So we're going to also multiply the top by root 5 plus root 3, because it's like multiplying, same thing, top and bottom is like multiplying by 1, which means the value does not change. So the numerator I'm going to distribute, so we end up with 2 root 5 plus 2 root 3, and the denominator, so when I square the first term, root 5 times root 5 is just 5, and then minus root 3 times root 3 is 3, so then we've got 2 root 5 plus 2 root 3, and that is all divided by 2. Well, look at that. Conveniently, we could factor that 2 back out of the numerator, and so that would actually leave us just with root 5 plus root 3 in this particular case then, because if you wanted to see that, we've got factor of that 2, so root 5 plus root 3, and that's all over 2, and so 2 over 2 is just 1. So that's why we end up with root 5 plus root 3. Okay. For the second question then, letter B. So again, our concern is that denominator, and even though that 2 does not have a radical, our whole denominator is root 6 plus 2. So if I just multiplied by root 6, that is not going to get rid of that radical in the denominator. So my only choice anytime I have a radical in the denominator, if it's a binomial, is to multiply by its conjugate. So we're multiplying then by root 6 minus 2, so we need to do that on the top and the bottom then. So in the numerator, we've got a perfect square, but we still need to do FOIL, or if you know the shortcut, you're welcome to do that. So root 6 times root 6 is just 6. In the outside, we've got minus 2 root 6, and the inside another minus 2 root 6, so it's minus 4 root 6. And then the last negative 2 times negative 2 is plus 4. In the denominator, because it's a difference of squares, I can square the first term, which is just 6, square the last term, which is 4, and it's subtracting, so 6 minus 4. So then the numerator, we can combine our like terms, so 10 minus 4 root 6, and that is all divided by 2. And so factoring out a 2, we're left with 5 minus 2 root 6. So again, if you need to, then you could factor out the 2 in the numerator. So we have 5 minus 2 root 6, and that is all over 2, and 2 over 2 is just 1. So that's how we end up with our 5 minus 2 root 6 as our answer. Okay, looking at letter C, then again, we've got that binomial in the denominator that has a radical, so I know that I'm going to multiply by the conjugate, so 1 plus root x on both the numerator and the denominator. And so the numerator, when I distribute, I end up with obviously just 1 plus root x. In the denominator, we'll square the first term, so 1 times 1 is 1, minus, and root x times root x is simply just x. And so it's 1 plus root x over 1 minus x. And remember, this is a sum or a difference. It is an all or nothing. So you cannot cancel out those ones. Do not be tempted to do that. That is your answer. That's as far as you can possibly go. Okay, so if we take a look then at class example number 2, and it says to express root 8 minus root 3 divided by 4 root 3 minus root 2 with a whole number in the denominator. So again, resist that temptation to do anything with the root 3's or anything with that root 8 and that root 2, because this is subtraction. So you can only reduce factors, not terms. So if you're tempted, put brackets on it. It's an all or nothing. So we've got options. If you wanted to start by switching that root 8 into root 4 times root 2 and 2 root 2, you can certainly do that. Numbers are still reasonably small, so let's just keep it as is. And so what we know is we've got root 8. I'm just going to rewrite this here so we have a bit more space, times 4 root 3 minus root 2. And so because I have that binomial in the denominator, I need to multiply by the conjugate, so which is 4 root 3 plus root 2. So we'll do that to the numerator as well as the denominator. Same thing, so that it's like multiplying by 1 over 1. So the value doesn't change even though the numbers appear to change then. So when we multiply this out then in the numerator, I need to go through and do FOIL. So, or box method. So root 8 times 4 root 3 is 4 root 24. And then the outside is root 8 times root 2, so root 16. And then inside, so negative root 3 times 4 root 3, so then that is going to be 4 times, and root 3 times root 3 is just 3, so minus 4 times 3, and then the last is going to be minus root 6. And then in the denominator, because they are opposites, conjugates there, so I can just go ahead, square the first term, so 4 times 4 is 16, and root 3 times root 3 is 3, and then the last root minus root 2 times root 2, which is just 2. So let's clean that up then, and I'm just going to come up here then, so 4 root 24, I'm going to simplify that root 24 to, root 4 times root 6, and then plus root 16 is also known as 4, minus 12 minus root 6, and in the denominator we've got 16 times 3, which is 48, minus 2. So then we've got 4 times root 4, or 4 times 2 root 6. So 4 times 2 is 8 root 6. And then 4 minus 12 is minus 8. Minus 8. Whoops. Minus root 6 over, and 48 minus 2 is 46. And then let's just do that final cleanup. So 8 root 6 minus root 6, that's combining like terms. So that is 7 root 6 minus 8 all over 46. And so again, that top term, that top binomial is 2 terms. So it's again an all or nothing. So you cannot simplify that 8 and that 46, leave those alone, because that is a subtracting in the numerator there. So that is your final answer. So again, if you wanted to check, you could always enter in the original expression into your calculator and figure out what that decimal approximation is, and do the same thing with your final answer. And those decimal approximations should be the same. Okay, let's take a look at that last example here. So class example number 3. So it says the area of a trapezoid is given by the formula A equals 1/2 of height times A plus B, where A and B are the lengths of the parallel sides, and H is the shortest distance between the sides, meaning that it's going to be perpendicular to A and B. So let me just draw this out for you so that you can see what I mean by this. So a trapezoid essentially is, a trapezoid is any shape, quadrilateral, that has exactly one pair of parallel lines, and so that is what's referring to A and B right there, and the height is going to be perpendicular to those parallel sides, so that is our height right here. So it tells us that, let's see, the area is 20 square centimeters. The parallel sides are root 6 and root 5. So I'll make this A is maybe equal to root 5 and B is equal to root 6. And we've been told that the area is 20 square centimeters. So it's asking for the exact value of the distance between the parallel sides, which is of course our height. So given that we have a formula, the easiest thing to do is to substitute everything into our formula itself. So I'm just going to rewrite this. A is equal to 1/2 H times A plus B, and substitute in what I know. So area is 20 is equal to 1/2 of H, which we are trying to find, times root 5 plus root 6. So currently this doesn't look like anything that we've seen. So our whole goal, of course, is to solve for H. That 1/2 perhaps can be a little confusing right now. So we know to isolate that variable, we need to do opposite operations. So first we're multiplying by 1/2. So if we want to kind of get rid of that fraction, if we multiply both sides by 2, then, so if I multiply the right side by 2 and the left side by 2, then new and improved is going to be 40 is equal to, and 2 times 1/2 is just 1. So it's H times root 5 plus root 6. So that looks much better already. And so, and some people might be asking, well, wait a second, why are you not multiplying the H by 2 and the root 5 and the root 6 all by 2? Is because, remember, these are 3 factors. So it's almost like if 1/2 was A and H was B and root 5 plus root 6 was C, then if I multiply it all by 2, then I'm not distributing 2 times A and 2 times B and 2 times C. That's only going to happen if we're addition. So they're all factors already, which is why we're not going to go ahead and distribute that 2 all the way through. So to isolate H, then I need to divide both sides by root 5 plus root 6. So that means then that that is just going to be 1. So we have H is equal to 40 over root 5 plus root 6. So that's a lovely expression, except it's asking us to provide the answer with a rational denominator. So that means no radicals in the denominator. That means we want to multiply by the conjugate of our denominator, so which is exactly the opposite, so root 5 minus root 6. Or creating, I shouldn't say exactly the opposite, but it's just changing those signs. So in the numerator, we will just distribute that 40, or we could leave it as well, that's fine. Technically speaking, we could, some people consider factored form simpler form, so that's just fine. In the denominator, difference of squares, so we'll square the first term, root 5 times root 5 is just simply 5, and minus root 6 times root 6 is 6, so we've got then 40 times root 5 minus root 6, and that is all over negative 1. So ideally, I don't want to leave that negative in the denominator, so if we just quickly multiply top and bottom by negative 1, so again it's the same thing, multiplying by 1, which doesn't change the value of it. So now I have denominator of 1, which is great, and then I've got negative 40 times root 5 minus root 6 in the numerator. So I would totally accept that. Other people might instead want to write negative root 5 plus 40 root 6, and that would be acceptable as well, because this has units on it and the height is centimeters, so it would be appropriate to indicate that that is our height. Awesome. Please let me know if you have any further questions. Thank you.